So this is just a series of videos looking at the different diagrams that we need to develop in order to do the mathematical calculations. So here what we're looking at in this case is what they call a space diagram. So this one here is a space diagram. Basically what we're seeing is the situation in real life. From here, we'll start to need to break this down because there's a lot of information going on here that we don't need. So the idea is to start to break this down and draw it in a way that we can understand and in a way that is easier for us to work through calculations. Okay, so for example, here I can see I've got a beam bridge. So that there is just going to be a straight line across there. Okay. I'm doing this freehand, so I apologise for this. In like better presentations, you might want to use rulers and your tools. Okay. So that's the first step that I've actually got in my FBD, or what that is called is a free body diagram. Basically what we're doing, we're stripping away all the stuff that we don't need and what we don't understand, like it's just causing confusion, which could muck up our calculations. Now staying with the drawing alone, like I can see over here, I've got all of this information. I'm not going to worry about that until the next video. We're looking purely at drawing the bridge here in a free body diagram. I know on one side of the bridge there's a pin, and on the other side is a roller. Doesn't matter what side you pick in this case, because you can see here there's no actual drawing of the pin or the roller. So again, we can determine it. For comfort's sake, because this is where I usually put them, I'm going to put the pin on this side. And on this side here, I'm going to draw the roller. Okay. Now these symbols are quite universal. Main thing is that you're looking at is the roller that has those three little wheels on it, and the pin is just a straight triangle. As I know that these are holding the bridge up, I know that there has to be a force here, and there is a force here. So to keep it quite simple, I'm going to call this force reaction right vertical, and on the other side, I know that this one is going to be called reaction left vertical. Again, it's just putting it in a language that I understand. Here on this side, we have the roller. So the roller itself is going to allow the bridge to have this horizontal movement backwards and forwards. So there's no force there. But on the other side, we do have a horizontal force because the pin's holding it in place. And I'm just going to call this reaction left horizontal. Okay? So that's just the naming conventions that I'm using here. I'm now going to come up to my bridge and let's just have a look at it. Here I can see I've got the truck. Okay? So I know that there is going to be a force in play on the truck down here. Also with this force, there's a second force, which is the weight of the bridge. So I've got the weight of the truck and the weight of the bridge. Here, there's going to be another force, and this force is also going to be the weight of the bridge, just as I have another force there, which is the weight of the bridge. So I'm just going to now come back to my drawing, because I want to fill those in. So here, I've got a force. I've got a second force about here, and then I've got the third force in the middle over here. Now, with these, again, I'm just sketching these in at the moment, but I can start to get some information. Here, I know that there is the back of the truck, the front of the truck, and then I've got my, so now I've actually can mark in these distances here. Little dimensioning arrows showing that I understand that. The final thing I need to do with this drawing is, because I've got the weight of the bridge, I know it's what they call a universally distributed load. And basically the signal for that are these upside down little U's. And I've got that here as well. All right. The only thing that I don't have here is, while I do have bridge weight, I've also got the weight of the truck. So I still need to add those up. What's important with these drawings, in understanding the drawings, are that these arrows that we're seeing, right, they all are in the middle. They're in the middle. So with the truck itself, the weight of the truck is in the middle of that truck. Okay, it's not on the end, it's not on the beginning, it's in the middle. And excuse me, it's also the same with the roads.